Think you know the whole story? Turns out you were probably taught the half-truth. Welcome to Half-Truths. Remember that feeling? You're a kid standing in the backyard. The grass is that impossible crayon green of early summer. You have a brand new fire engine red ball, slick and perfect. You rear back, you throw it as hard as you can, and you yell, "Go get it, boy." And your dog, your best friend, tears off, bounding joyfully, right past it. He stops, sniffs the air, head cocked. And you sigh, and your dad, leaning against the doorframe, chuckles and says, "You know, he can't even see that red ball. It's all just gray to him." And just like that, a fact is born. It lodges itself in your brain with the same certainty as the mitochondria is the powerhouse of the cell, or Christopher Columbus discovered America. Dogs are colorblind. Completely. They live in a grayscale world, a beautiful, noble black and white film. While we get to enjoy the full Technicolor experience, it's one of the first and most fundamental pieces of animal trivia we learn. It defines our relationship with them. It explains why their sense of smell is so good. They have to compensate, right? But what if that story, that simple, clean, universally accepted fact, isn't the whole story? What if that tidy explanation we've been carrying around since childhood is just another one of those half-truths? What if we've been looking at our best friends and seeing their world all wrong? Welcome to Half-Truths. Today, we're unlearning what we think we know about dog vision. We're going to pull on that thread and find out if Fido really lives in an Ansel Adams photograph, or if the truth is something far more surprising and, frankly, far more vibrant. The story we all know is simple, and that's a big part of its appeal. Humans, we're told, are the visual creatures. We evolved to see the full, glorious spectrum of light. We can tell the difference between a ripe red apple and an unripe green one. We can appreciate a sunset with its oranges and purples and pinks. Our world is defined by color. Dogs, on the other hand, got a different deal. The popular myth says that in the great lottery of evolution, dogs traded color for something else. They traded our high-definition Technicolor world for a superior world of scent and sound. Their eyes, the story goes, simply don't have the biological hardware for color. They see the world in shades of gray, from the brightest white to the deepest black. And this fact has shaped everything about how we interact with them. It's been a staple of pop culture for decades. How many times have you seen a movie or a TV show that switches to a dog's eye view, and the screen suddenly desaturates, becoming a grainy black and white shot? It's a universal visual shorthand. It even influenced an entire industry. For years, dog toys were made for us. They were bright red or bright green or safety orange. We bought them thinking that the brightness, the contrast against the grass, was what the dog was seeing. We thought a bright red ball on a bright green lawn would be a high-contrast target. To our eyes, it is. But if the world is just shades of gray, maybe a bright gray on a slightly different bright gray is all that matters. There's something almost romantic about the myth, isn't there? It paints the dog as this noble, unpretentious creature. They're not distracted by the superficiality of color. They're focused on the essence of things, the smell of a rabbit, the sound of your key in the lock. It reinforces a narrative that makes us feel special. We have this rich, complex visual world they can't access, and they have this mysterious, powerful scent world we can't access. It's a neat, tidy separation. This idea became dogma. It was repeated in textbooks, taught in biology classes, and passed down from parent to child for the better part of a century. It was simple, it was memorable, and it came from a place of science, except it didn't. Not really. So, where did this colossal fact come from? Was it an ancient piece of wisdom? No, was it the result of a landmark Nobel Prize-winning study? Not even close. Like so many half-truths, its roots are surprisingly shallow and surprisingly unscientific. The idea that dogs see in black and white was largely popularized by one man, a dog enthusiast and publisher named Will Judy. In the 1930s, Judy was a huge figure in the American dog world. He founded Dog Week magazine and wrote extensively on dog breeding and training. He was, by all accounts, a man who truly loved dogs. But he wasn't a biologist. He wasn't an ophthalmologist. He was an aficionado. And in a 1937 training manual, he made a claim. He wrote that it was likely that dogs could only see in shades of gray. His evidence? It was based on very early, very primitive behavioral experiments. These experiments were rudimentary, to say the least. Scientists would try to train dogs to distinguish between different colored objects. For example, they'd present a dog with a dark red card and a dark green card and try to train the dog to choose one over the other for a treat. The dogs, by and large, failed. They couldn't seem to tell the difference. From this failure, the researchers and popularizers like Will Judy made a gigantic logical leap. They concluded that because the dogs couldn't tell red from green, they must not be able to see any color at all. This is a classic, textbook example of a scientific error, taking an absence of evidence for one thing and treating it as evidence of absence for everything. They didn't stop to ask, well, what if they can see other colors? They didn't stop to ask, what if red and green just look the same to them? No, the conclusion was simple, sweeping, and wrong. No red-green distinction must mean no color, period. And that was that. The idea was so simple and so easy to repeat that it just stuck. It became gospel. It was published in magazines, then repeated in books, then taught in schools. For more than 50 years, this fact, born from a flawed assumption, was the undisputed truth. No one really bothered to challenge it because, well, why would they? It seemed to make sense. It fit our narrative. The problem, as is so often the case, wasn't that the observation was entirely wrong. The dogs couldn't tell the difference between red and green. That part was true. The half-truth was the conclusion we drew from it. The real story, the one that scientists didn't uncover until much, much later, was lurking inside the biology of the eyeball itself. The real record-scratch moment for the scientific community came in the late 1980s and early 1990s. A handful of researchers, armed with new technology and a healthy dose of skepticism, decided to stop guessing what dogs saw and actually go look at the tools they use to see. Instead of just focusing on behavior, they focused on anatomy. To understand what they found, we have to do a quick, painless dive into how an eye works. Any eye, yours or a dog's. Inside your retina, at the back of your eyeball, you have two types of light-detecting cells, rods and cones. You probably remember this from high school biology. Rods are for low-light vision. They're great at picking up motion and seeing in the dark, but they don't see color. They're your black and white sensors. Cones are the rock stars. Cones are for color, and humans, we are special. We are trichromats. Tri meaning three. We have three different types of cone cells. Each type is tuned to a different wavelength or color of light. We have cones for red, cones for green, and cones for blue. Think of your brain as an infinitely sophisticated mixing board, and these three cones as the primary inputs. By mixing the signals from your red, green, and blue cones, your brain can create every color you've ever seen. The purple of a violet, the orange of a sunset, the millions of shades in a painting. It's an RGB monitor built from biology. So, for decades, the assumption was that dogs either had no cones at all, or their cones were non-functional. when scientists like Jay Neitz, a vision researcher at the University of California, Santa Barbara, finally did the anatomical and genetic work, they looked inside the dog's retina. And what did they find? First, they found that dogs have a ton of rods, way more than we do. This immediately confirms something every dog owner already knew. Their night vision is incredible. But that wasn't the discovery. The discovery was that when they looked for cones, they found them. Dogs have cone cells. They are not completely colorblind. But here's the aha moment. Here's the pivot point where the half-truth breaks and the real story begins. They didn't have 3 types of cones, they had 2. Dogs are dichromats, D meaning 2. This changes everything. They aren't living in a black and white world. They're living in a dichromatic world. So the next logical question is, which 2 colors? They have cone cells for blue, and they have cone cells for, well, it's not quite our green and not quite our yellow. It's a shade somewhere in the middle, best described as a yellow-green. What are they missing? They are missing the cone for red. Let that sink in. Dogs do not have the biological hardware to perceive the color red. They also, by extension, have trouble with green, which in our trichromatic brains is perceived by comparing signals from our red and green cones. So, what does the world actually look like to a dog? It's not a world without color. It's a world painted in a different palette. Their entire visual spectrum is made up of shades of blue and shades of yellow. And you know who else has dichromatic vision? Humans. About 8% of men and 0.5% of women of Northern European descent have what we call red-green color blindness. This isn't a disability. It's just a different way of processing visual information. And it's the exact same hardware setup that dogs have. Your dog sees the world in a way that is strikingly similar to a human with red-green color blindness. Now, let's go back to that backyard, that fire engine red ball on the lush green grass. To your human trichromatic eyes, it's a vivid, impossible-to-miss contrast, a bright, warm color against a bright, cool color. To your dog's dichromatic eyes, that red ball and that green grass are perceived as 2 slightly different shades of the same color. It's a muddy brownish-yellow object sitting on a slightly different muddy brownish-yellow background, or in some lighting, they might just both look like shades of gray. That ball doesn't pop, it's camouflage. Your dog wasn't being dumb. He wasn't ignoring you. He literally could not see the toy. Now, let's run that experiment again. This time, you're in the same green, grassy yard, but instead of a red ball, you throw a blue ball. To your human eyes, a nice blue ball on green grass, pretty. To your dog's eyes, a brilliantly, stunningly, vividly blue object against a dull, muddy, brownish-yellow background. That ball shines to them. It's a beacon. It's a high-visibility neon sign screaming, "I am here." The same goes for a yellow ball, which would appear as a bright yellow against a dull, muddy-colored background. This is the truth. This is the payoff. Dogs see in color, just not our color. Their world is a rich and vibrant landscape of blues and yellows. The red parts of our world, from a stop sign to a rose to that expensive toy, are just a dull, drab, brownish gray. And the green parts, also a dull, drab, yellowish gray. This is why, in recent years, you've suddenly seen the dog toy market flooded with products in dog-specific colors. The ones that are bright blue or bright yellow or even purple, which dogs would see as a shade of blue. This isn't a marketing gimmick. This is science finally catching up to reality. We are at last designing toys for their eyes, not for ours. But the story of dog vision doesn't end with color. because color is only one piece of a much larger, more fascinating sensory puzzle. The myth wasn't just wrong about color, it was wrong about what a dog's eye is for. We, as primates, evolved to be high-definition, color-first creatures. We needed to see that ripe fruit. We needed to be active during the day. A dog's eye is a different piece of technology, built for a different purpose. It's a predator's eye. Specifically, it's a crepuscular predator's eye, meaning it's optimized for dawn and dusk. We already mentioned they have more rods. This, combined with a structure behind their retina called the tapetum lucidum, which is what makes their eyes glow or shine in the dark, means their night vision is profoundly better than ours. They can see in light that is 5 times dimmer than what we would need. They are, in a very real sense, walking around with built-in night vision goggles. But here's the trade-off. All those rods and that light-bouncing tapetum come at a cost: clarity. You know how you can focus on a single word on this page, and it's perfectly crisp? That's thanks to a little pit in your retina called the fovea, which is densely packed with cones. It's your high-definition sweet spot. Dogs don't have a fovea. Their sweet spot is much less dense. The result? Their vision is, by our standards, blurry. What we can see with 20/20 sharpness, a dog sees with roughly 20/75 vision. This means that an object you can clearly identify at 75 feet away, a dog would need to be just 20 feet away to see with the same level of detail. So, their world is blurrier, but it's also wider. Our eyes are set front and center, giving us great depth perception, but a relatively narrow field of view, about 180 degrees. A dog's eyes are set more to the sides of their head. This gives them a panoramic field of view of about 240 degrees. They can see much more of the world at a glance, including things that would be in our blind spot. And finally, their eyes are hypersensitive to one thing above all else: motion. Their visual processing is tuned to detect the slightest flicker or twitch. A rabbit sitting perfectly still on a gray-brown hill might be invisible to them. But the second that rabbit's ear twitches, it's like a neon sign lights up. Their eyes scream movement, and their prey drive kicks in. So let's put all the pieces together. The real story of dog vision isn't a simple downgrade from our own, it's a completely different operating system. A dog's visual world is not a black and white film. It is a widescreen, panoramic, slightly blurry world, painted entirely in shades of blue and yellow. It's a world where reds and greens fade into a uniform, muddy background. It's a world that is incredibly dim to our eyes, but perfectly functional to theirs. And it's a world where a tiny, distant movement is the most interesting, most compelling, and most visible thing in the entire landscape. It's not worse vision. It's different vision. It's a visual dashboard perfectly tuned for the life of a hunter, a scavenger, a companion who needs to see you moving in the twilight. So, we've come a long way. We started with a simple, comfortable, and condescending myth. Dogs live in a gray, colorless world. A story that, it turns out, was born not from serious science, but from a flawed assumption made by an enthusiast half a century ago. We pulled on that thread, and we found a truth that is so much more complex and so much more fascinating. We found a dichromatic world of blues and yellows. We found an eye built not for high-definition clarity, but for wide-angle motion detection and low-light survival. Why does correcting this half-truth matter? It's not just about winning a trivia night. It's about empathy. It's about fundamentally changing how we see a creature that we share our homes and our lives with. When we believed the black and white myth, we were defining our dogs by a lack. We were defining their entire reality by a human-centric standard and finding it lesser. It was easy to think of them as these simple, color-deprived beings who navigated by scent alone. The truth forces us to do something more difficult and more rewarding. It forces us to try and imagine a different kinplay of consciousness, a different sensory world. It forces us to ask, what is it really like to be this animal? And it has practical, tangible consequences. It changes how we play. When you stand in the pet store, you are now armed with knowledge. You can skip the fire hydrant tread plush toy and pick up the royal blue one. You can stop throwing that red ball on the green grass and wondering why your dog seems frustrated, and instead, choose a toy that you know will light up for him. This is a perfect example of a half-truth. The original observation that dogs don't see red and green like we do wasn't wrong, but the conclusion we drew from it, that they see no color at all, was a massive oversimplification that obscured a much more interesting reality. We mistook a different palette for a blank palette. The next time you look at your dog, truly look at them and try to see the world not as you do, but as they do. You might just realize that the world we've been missing is theirs. Now you know the real story. What other half-truths are still out there? If you enjoyed this episode, please subscribe, leave a comment, and join us next time. Until then, stay curious.